Hello students, welcome back. In the last period we have seen that last technique, fifth technique of chromatography, along with the chromatography sublimation we have seen, then decantation using separating funnel, centrifugation and evaporation. Okay, so these are the techniques that we have studied in the last period, and I hope these techniques you have learned properly. Okay, so chromatography was the last among them, which means that chroma means color, graphy means separation. So chromatography is nothing but the separation of different colored components from the mixture. Okay, the colored components are separated on the basis of different dissolving rate. Okay, the different dyes dissolved in different speed in the water. So on the basis of that, the one which dissolves faster rises up, the one which dissolves slowly remains down, and the two components are separated from the ink, and then that's how we can separate that's how we can use the chromatography for the separation of colors. Okay, so let us go to the next method of separation is distillation. Okay, it's very important diagram. It's very important diagram. Okay, distillation assembly. So see, distillation is nothing but the separation of mixtures or components of miscible liquids by boiling the mixtures and cooling and condensing the vapors. So what happens in this distillation? First of all, distillation it evaporates the liquid. Okay, ये क्या करता है? First it evaporates, and then after evaporating we again condense it. It is again condensed. So evaporation and then condensed. So after once we evaporate, the mixtures are evaporated first, the components of the mixtures are evaporated first, and then it is cooled down and condensed back. Okay, so that's how this technique works. But what we require is, here there should be difference in boiling points. Okay, well, when we apply this method for separation of the components, we must have the components of the mixture must have difference in boiling points. Remember this. Now you know what is boiling point, the temperature at which any particular liquid starts boiling. Okay, suppose A and B is the two components, and when you mix them, that forms the mixture AB. And if you want to separate this AB from the by using the distillation technique, then A and B must have different boiling points. If they have a very similar boiling points, like one is having 25 and another is also having 25, then the distillation will not work. So if the difference in boiling point is there, then the components of the mixture can be separated by using the distillation. So for definition, we can say that this method is used for separating the mixtures of miscible liquids. Which liquids? Miscible liquids. Like for example, oil and water is there, so we can use the decantation by separating funnel. But if the mixture, because they are immiscible liquids, but if the mixtures components are miscible in each other, say for example petrol and kerosene, okay, there is a miscible liquids. These two are miscible liquids. Like petrol is miscible in kerosene. So nowadays adulteration of petrol is a very big problem in many areas. This petrol is adulterated means it is mixed with some kerosene, and people are doing malpractice. Okay, so this is you can check whether this petrol is pure or not by using the distillation technique. So for that we require to have this distillation ceremony, distillation flask, not distillation flask or distillation assembly. Okay, so this distillation is it's a kind of a process. Okay, distillation is a process where two steps takes place. First of all, evaporation, as I told you, and then condensation. So there are different types of distillation: simple distillation process and fractional distillation process. So fractional distillation is used for different purpose. Okay, but here we are going to talk about the simple distillation technique first. Okay, so I hope the concept is clear. First of all, the components of the mixture which is having difference in boiling point will be evaporated. The one which has low melting point, sorry, low boiling point, not melting, low boiling point will evaporate first. The one which has low boiling point will evaporate first, and it will start condensing, sorry, it will start evaporating, and then it will condense down in the condenser. Okay, unless entire A, suppose if the mixture of A and B was there, suppose A is having low melting point, so this temperature will be achieved first, right? And then A will start evaporating. When A will be evaporated, that time B will not receive the heat. As we know that latent heat of evaporation, we have seen that latent heat of evaporation, unless the entire A will not be evaporated, the temperature will or heat will not be received by B. So here what we have to do is, now see, let me explain by using the diagram, because it will be easy to understand by the diagram only. Okay, see, first of all, let us see simple distillation, what it is. It is used to separate the mixture of two miscible liquids having sufficient difference in their boiling points. Sufficient difference in their boiling point, this is an important word, the important concept of this simple distillation technique. So we need to have a sufficient difference in their boiling points, and then we can use the simple distillation maker. Now see, if a mixture of acetone and water is heated in a distillation apparatus, now this is the distillation apparatus. Okay, this is the distillation apparatus. Now if you heat the this one mixture of acetone is volatile. Okay, as we know that acetone, if it is kept open, it automatically evaporates at room temperature only. It evaporates. It means that it has low its boiling point is less than room temperature, right? No, that's why only it is evaporated. But water, when you keep the water open in the surrounding, does it get evaporated? No. Reason that its boiling point is more than room temperature. That means as everybody knows, the boiling point of water is 100 degrees Celsius, but acetone is getting and room temperature is around 25-30 है ना. So if any liquid is getting evaporated at that temperature means room temperature पे अगर कोई liquid evaporate हो जाता है, इसका मतलब ये है कि that particular component of the mixture is having low melting point, boiling point than the room temperature, that is below 25 degree Celsius, right? Now, so this is the mixture of acetone and acetone and water. So the acetone which has lower boiling point, than the water, first boils and cools and condenses, and it is separated from the water. So the one which has low boiling point will be evaporated first. Okay, and then it will be condensed back. It will be evaporated and it will be condensed back in the that receiver. Okay, or as a distillate. Okay, so now see, this is the distillation technique. Okay, where let me explain you this entire assembly, okay, of distillation. See, this one, these are the different let me explain you about the different apparatus used here. This is a metal stand. Okay, this is a metal stand. Then here this is distillation flask. ये है आपका distillation flask. Then Bunsen burner. This is a collector, receiver, which collects the distillate. Okay, then this is Liebig's condenser. क्या बोलते हैं इसको? Condenser, but its name is Liebig's condenser. Okay, then here is a thermometer here. Okay, thermometer is there. Then here we can insert the water here. Okay, यहाँ पर cold water. Now this condenser is like a hollow tube in which there is one more tube, and around this tube there is a layer of water. Okay, तो इसके आजू बाजू में यहाँ पर पानी भरा जाता है. From one side cold water comes in and the other side cold water goes out, and in between these vapors runs. Okay, तो यहाँ पर ये जो vapors है, the vapors runs from this inner tube. Okay, and when these vapors runs through this inner tube, the surrounding, which is cold because of the cold water inserting cold water, due to this cold atmosphere, these vapors get condensed and then they are collected here. Okay, in the receiver as a distillate. So this is about the different apparatus. Now let us see the process how it takes place. Uh, See this when these components of the mixture, now uh, components of the mixtures are here. Suppose we have taken the mixture of acetone and acetone plus water, and as we know acetone has a lower boiling point than water. So when we start heating, now here heating is going on. So as we start heating, the this component which is having low boiling point will start evaporating first. So let us begin the evaporation process. Now thermometer is placed to see the reading, okay, at which temperature this particular component is getting boiled. So here boiling is started, and as the boiling start, you can see the vapors, okay, the vapors of the component of that particular mixture, okay, components of that mixture is getting condensed here. Now you can see here these are they are getting condensed here. You can see condensed, and then here drop by drop this condensed, okay, drop by drop it is going on, okay, the collection is going on. So this is about the condensation process. Now once this a component, suppose acetone is getting separated, suppose once entire acetone is separated here, then we have to change this beaker here, okay. Once this entire acetone is getting evaporated and condensed collected in this receiver as a distillate, we have to change this receiver, and we have to keep another receiver here. And then see at that time what will happen, the temperature will stop rising. See, when acetone was being evaporated, that time temperature will stop at that particular temperature, suppose 25 to 26 डिग्री सेल्सियस पे वो रुक जाएगा, और उसके थोड़ा सा पहले ही 22 पे temperature will stop rising, because now the acetone has started boiling. Now temperature will stop rising. Reason that the heat which is being given now will be used to convert the state of acetone into vapors. If you remember the latent heat of evaporation, latent heat is the heat absorbed by the particular liquid, 1 kg of that particular liquid, to change that liquid into a gaseous state. That is called latent heat. Hidden, that heat is hidden. So that heat is absorbed and the temperature does not rise, okay. Heat is being absorbed but temperature doesn't rise. It means that is a hidden heat which is used to change the state of, if you remember, we have studied in the first chapter that temperature does not rise because of the change in state, the heat used for the change in state of the matter, okay, and that heat is called as latent heat. So here the same thing happens when acetone is being boiled. That time the temperature stop rising, because now whatever heat is given, that is used to absorb change the state of acetone to gaseous state. And then when entire acetone is evaporated, then automatically these droplets will stop falling from the condenser. Now you should understand that, and at the same time you will find that the temperature is rising in the thermometer. So it's a very keen observation required for this. It requires a very keen observation. So you have to keep observing. As soon as the droplet stops falling from the condenser, the temperature will start rising, and you should understand that this is the time we need to change the receiver. This is receiver means what, which is the receiver? This is receiver. So this receiver we need to change, because now one component is entirely separated, and as the temperature is raised, now when boiling point of second component or B component, that is water, will be achieved, that time the evaporation of water will start. Now what at what temperature that evaporation will start? At 100 degrees Celsius. When temperature will rise at 100 degrees Celsius, then the water will start evaporating, and then the condensation will start, and then droplets you will see again falling down from the condenser. So we have to evaporate that entire water, and when distillation flask, that is this distillation flask, is empty, you have to stop heating, and then your that component will be also separated from the distillation flask or that mixture. So this is how this technique works, okay. So this is a simple distillation, so which works on the difference in boiling point of the component of the mixture. So you know, so this is how this distillation works. Okay, now here you can understand that thermometer is there. Okay, mixtures, acetone plus water, metal stand, okay, Bunsen burner, distillation flask, then cold water, outlet, then from here cold water inlet is there, then this is Liebig's condenser, acetone is collected here. Okay, so these are the different apparatus, names of the apparatus used in the condensation process, and which makes entire assembly of distillation. Okay, so I hope this method of separation is clear. Okay, now let us go to the next technique, that is fractional distillation. Okay, now this fractional distillation is again entire different, little bit different from the previous one. Okay, so I suggest you read this technique. Just pause the video and read this technique, and we will understand this tomorrow in the next period. Okay, that's all for today.